So welcome to the fourth mini webinar in the respiratory fit testing. And this time we will talk about the quantitative fit testing and specifically the CNC technology. A few practical points. So for the audience, you are all automatically muted and your video is out. If you have any questions, don't hesitate to put them in the Q&A feature in the webinar system, and we will take them at the end of the webinar. To know that the webinar is recorded and will be made available in the next days on the ESF YouTube channel. And here you have the link to the YouTube channel. You will also find there the 3 previous webinars or the recording of the webinars. So don't hesitate to check that out. For those who would not know ESF, European Safety Federation. So we are the organization of suppliers of personal protective equipment, focusing on the professional use of PPE, with representation all over Europe. Our first layer of members, also founding members or national organizations in different countries. And apart from that, we also have companies and industry stakeholders that join us as an organization. Next slide. This series of webinars is organized by the working group Respiratory Protection. The working group has about 25 members from 15 different countries, so well spread from all over Europe, and also a mix of companies and national organizations. All of the members are also involved in different committees. Think about standardization, for instance. And the work of the working group is mainly research on respiratory protection and fit testing, also awareness campaigns, and you could say that this webinar is an example, and also education on respiratory risks. We are running also a series of mini webinars on respiratory risks in the construction industry, for instance. That one is running every last Friday or every second last Friday, but we don't have one next week. The next one is in September. And also those are on our YouTube channel. So next slide. Yeah, today our presenter will be Janina Sander. She happens to be also the chair of the working group Respiratory Protection, but today she's mainly here in her function as application specialist at TSI. So with that, Janina, I give the floor to you.
Thank you very much, Henk. So now the people see me as well. Thank you, Henk, for the introduction, and welcome everyone, also from my side, to today's webinar. I will give, as Henk said, today as my job for TSI, a presentation about quantitative fit testing, abbreviation QNFT, on the CNC technology as part of our ESF series respirator fit testing. And just to give you a hint on why the title is quite long for this session, I want to give you start with a short overview on how to fit test respirators. And in general, you can fit test respirators with 2 different methods: qualitative fit testing, where you have a subjective evaluation by smelling or tasting a specific test substance. This technology was presented in the last session of the ESF webinar, which you can find on the YouTube channel. And it was the special thing about this technology is that it is only allowed for disposable and reusable half masks, but not for full face masks. And this all is about qualitative fit testing. And on the other hand, we do have quantitative fit testing as the second method, where there is the common thing that you do have a measuring instrument which is connected to your respirator. The measurement instrument can do different things, use different technologies. Both are quantitative fit tests, but therefore we split it up in quantitative fit testing CNC technology, what I will talk about today. CNC as condensation nuclei counting, also called APC, ambient particle counting in the UK area. Both terms describe the same measurement technology and procedure where we perform a concentration determination inside and outside the mask. The second quantitative technology is the CNP method, the controlled negative pressure method, which is presented in the next webinar session, series session. So I today will focus on what you see here in yellow is the CNC technology part. In general, quantitative fit testing is suitable for reusable half and full face masks, so you can cover all required minimum fit factors. And with the CNC technology, you can also test disposable masks. So the CNC technology is the only fit test method where you can test all types of tight-fitting respirators available. And one instrument that is using this CNC technology is the TSI instrument Porter count. There are, of course, other instruments on the market as well, but as I'm from TSI, I can only talk about our instrument in detail. And just as a general introduction, the Porter count is specific designed for quantitative fit testing, for an objective evaluation of a respirator's fit by counting particles and determining the concentration in the ambient air and inside the respirator. And as I said, as this is using the CNC technology, the instrument is suitable for all types of tight-fitting respirators, from FFP masks to a full-face respirator. Maybe to start with the very basics and the measurement concept of CNC. That's quite important to understand why the instrument is measuring what it measures, and also how the evaluation of the fit takes a role. So the measurement concept behind CNC is that if you're wearing a tight-fitting respirator and you're breathing through the filters of that respirator, and you have a good fitting respirator, you do have your hazardous air in the outside, you breathe through the filter, and inside the respirator, you don't have this hazards anymore. If you have a poor fitting respirator, you have your hazardous air outside, but due to physics, as the air always takes the way of least resistance, you are breathing in through leakages and not through the filter material. And of course, through leakages, you breathe in the hazardous air without it being filtered. So inside the respirator, you also find this hazards you want to protect yourself for. And this is what we are using in the CNC technology with particles as measurement fluid. So you can also use it for fit testing respirators that are used against gases hazards. We are just using the particles for our measurement as a fluid. So the idea or the concept behind CNC is that if we have a good fitting respirator, we have lots of particles in the ambient air and a very low concentration inside the respirator, while if we have a poor fitting respirator, we have a high concentration outside as well as a high concentration inside the mask. And this leads us directly to the value we are using to evaluate the fit, which is the fit factor. The fit factor is the ratio between outside concentration, so the ambient concentration, and the inside concentration, so the concentration inside the respirator. And in the case of good fit, we do have lots of particles in the ambient air, but just a very low concentration inside. And then the fit factor is a high value. And the more particles we do find on the inside of the respirator, the lower the fit factor will become. And therefore, the lower or the less the fit is. So the lower the number, the less fit it is. In general, CNC, as I said, is the abbreviation for condensation nuclei counting. So the concentration, the ambient concentration, as well as the concentration inside the respirator is calculated by the flow of the measurement instrument and the count, the number count of particles that the instrument counts in the air. In general, it is important for this fit factor idea that you do have a sufficient number of particles in the ambient concentration. So if you imagine you have a very low number of particles here in this box, you can't find a higher number inside the respirator, even if the mask is not fitting. So you do need a sufficient number of ambient particles that you really can say, if I don't find particles inside the mask, then this is due to a good fit and not just due because there couldn't be more particles come in as there wasn't more outside. And so this is the first thing you need to take into account. And the second thing you need to take into account is that this fit factor idea and calculation has the prerequisite of a good working filter. Because if you have a broken filter, for example, at your respirator, then there are lots of particles coming into the mask, but through the filters. And we can't think about all particles that we measure inside the mask come in through leakages. I will talk about that one in a few slides again. So in general, the fit factor, the value we use to evaluate the fit of a mask is the ratio between outside concentration to inside concentration. And we do that by counting particles. And when I say particles, I talk about very, 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 very small particles. So imagine this being a human hair, and a human hair in average has a 60 micrometer diameter. On this hair, you do see in true scale these blue particles. They are in true scale to the human hair here on the slide at 10 micrometer particle. On the blue one, if we zoom in, even if in this big one here, you do see in true scale the yellow ones, which are particles with a diameter of 2.5 microns. And on that, you do see this tiny green particle, and this green particle have a size of 1 micrometer. So you can imagine that this is a size on a real human hair you would not see anymore. This 1 micrometer is the upper size limit of the Porter count from the measuring range of the Porter count. Why is it? Why are we measuring this very, very small particles? Because in this size you have lots of hazardous substances with the same size you want to protect yourself for, but it's also because this small particles starting from a size of 20 nanometers are so small that they behave the same as gas molecules. So the movements, how these particles move in the air is the same as with gas molecules, the so-called Brownian molecular movement. And this is the reason why the CNC technology, even if it's measures particle, can be used as representative for fit testing also of respirators that should protect you against gases. You might now be interested in how are nanoparticles measured, and this also explains this strange title of the technology, CNC, condensation nuclei counter. You need to know that the instrument, from a just technical perspective, is usually called condensation particle counter, CPC, while the fit test technology is called CNC. This is due to whatever reason back in history when it first was put into the paper, but it means the same, just for you to know. And in this instrument, this is a schematic drawing of a Porter count on the right hand, you do have a first part of the instrument, which is the saturator. The saturator evaporates alcohol to create a supersaturated alcohol vapor. Then the particles that we measure from the ambient or from inside the mask flow through this area of alcohol vapor, mix there. This mixture is going to the condenser. In the condenser, the mixture is cooled down and the alcohol vapor starts to condense. And due to physics and how we set the instrument settings, we can make the droplets which condenses to be condensing on the particle surface. So you can imagine a particle with lots of small alcohol droplets on its surface. And while the condensing is ongoing, we have more and more alcohol condensing, the droplets on the particle surface becoming bigger and bigger until they form a complete layer around the particle. So you could think about the particles enlarging, but being enlarged by the alcohol layer. Or you can think about a droplet with a particle nuclei. And this is why this name CNC came. What that makes is that when there's more and more alcohol condensing and this alcohol layer becomes bigger and bigger, the particles become significantly larger and become that large that a photodetector can count them. So every single particle goes through a laser, area with a laser, and scatters light, and the photodetector detects, oh, there's a particle scattering light. And with that, we can count the particles. And because we know the flow of the instrument, we can calculate the concentration in the ambient air as well as inside the respirator. That's the technology. And that works fine. But I said that we do need one prerequisite, which is a very good working filter, so that we really know that all the particles we are counting from inside the respirator are coming in through leakages and not through a bad filter. That's easy if you have a reusable respirator, because if you in your all-day work use it with a P2 filter element, that's fine. For the fit test, you just switch to a P3 filter element. That's easy. That's needing 20 seconds to change the filter. But if we are working with FFP2 or even FFP1 respirators and want to test them, we can't just change the filter material. And therefore, we do have a special technology developed, which is called the N95 companion. And this companion technology uses a special physical behavior of filter material. Filter material don't have the same efficiency for all particle sizes. They have a very good filter efficiency, near 100% for very, very small particles. Then they have a drop, and it goes up to near 100% for bigger particles again. So in this area where we have the lowest filter efficiency, we are talking, or call it the MPP, the most penetrating point. So this particle size is for this filter, this is just an example, the size which penetrates the filter the most. So what we do in the N95 companion, we say, hey, it's nice that we have an issue with this particle size. We don't care about this particle size because we only take a look at this particle size where we know that the filter efficiency is back up to near 100%. So we are fulfilling this prerequisite if we are only taking a look at this particle size. So what we do for testing FFP2 or FFP1s, we are shortening the measuring range of the Porter count to a smaller area to be able to avoid the MPP and be in the area where we know that all particles we measure inside are coming in through leakages. This technology, of course, should only be used for FFP2 and FFP1s because with making the measuring range smaller, we also reduce the amount of ambient concentration of ambient particles within the size range. So this should be used only for FFP2s and FFP1s or N95s. That's why it's called N95 companion. And for your reusable mask, always switch to the P3 filter element. So that's the details about the technology. And it's quite technically, but there's things, I call it more advantages of using quantitative fit testing and a CNC technology, because it's not only the instrument doing some technical stuff, it's also the process of how fit tests are conducted, which is changed because you're using a technical instrument which, for example, has a software. So if you're working with a port account, you have a software with nice screens, with a database with all respirators you're testing in, which you can create. You have a database with all the people you're testing in. And if you want to conduct a fit test, you just open the I want to start a fit test screen and press the start button. And afterwards, you get animations that help you through the fit test according to the protocol you selected. That makes process for the fit test operator easier. You don't need to calculate or think about the results on your own because the instrument is developing or calculating the result, and you just get a green screen or a red screen. You'll pass the fit test or you failed the fit test. There's also with the CNC method the big advantage that next to performing a complete fit test according to protocol, you can use real-time measurements. In the port account, it's called real-time fit check mode. And this is a quite proven in practice method, which you can do before starting the fit test cycle, just to check the fit of the respirator so that you don't need to waste time that after the fit test you found out that the mask doesn't fit. You can check that before. So use the real-time fit factor before to just simply see quickly, does this mask look good or is it a very bad fit? Then we don't need to start the fit test. You can also use it for testing, for adjusting, for people who are new in wearing respirators as a training tool to say, put it on as you think it's correct. And now I'm telling you what you need to do it, how to do it correctly. And they can see in live from how the fit changed, for example, from red to green. So that allows you time savings by quick detection of ill-fitting mask, try out different fit options and rapid sorting out. And then you only need to start the fit test, the real fit test, if you have a certain degree of certainty that the fit test will pass. Software also allows always documentation, so you don't need to write a fit test report by hand. It's delivered by the software of the instrumentation of quantitative instruments. Like here, that's an example fit test report from the port account with all the details. I don't go through all the details in detail, but just to see that all the details that the protocol requires to have included in a protocol and a report are just there without you doing special things. Measurement instruments also allow you to use advanced software like cloud-based solutions. The TSI solution is called TSI Link Cloud with different features. But as I said, it's something general that measurement instruments can do is they just allow you more than if you start with a sheet of paper in a manual fit test. One last thing I would like to present about the CNC technology is something how you can see how fit testing moves on. Because while we have the fit test instrument for a static fit test, the CNC technology is also used for fit assurance instrumentation. So like the same technology as I explained for a CNC fit testing can also be used in wearable systems to perform real-time respiratory fit assurance or simulated workplace protection factor studies. And it's exactly the same principle as used in CNC fit test machines, with the only difference that this variable system is using distilled water compared to isopropyl alcohol, which is used in the port account machine here. So this is just, of course, that's one of our instruments. I don't want to go into the product details as this is an education webinar, but just to show you that there is possibilities using this technology for more knowledge about fit of respirators than just the fit test. And with that, I'm through my presentation and looking forward to your questions.
Okay, thank you, Janina. I see there's a question in the chat for the companion technology. If I understand the question correctly, it is, does this companion technology allow to be used by a non-ethical fit tester to let a poor filtering material respirator pass the fit test?
No, that's the good answer here. No, it could not be used, because if you have a poor filtering material, you are not here back at 100%. So if you have a poor filter material, the whole graphic drops. So you are most probably even much below 90, so out of scale of this graphic. So you are not in this area here. So you're also much lower. You might still have this form, because poor filter material is very poor. So it's just a might, but you're not here at 100%. So you can't use the N95 companion to make something better than it is.
Okay, and in the Q&A, I see a question: are there ever zero particles present in a CNC fit test?
Let's say from a mathematical point of view, not, because if I go back to this slide here, if I would have inside my respirator zero particles, it's mathematically not possible to calculate a fit factor. So to be able to calculate a fit factor, you always 0.1 or something, I think, is the factor we put in as just to be able to mathematically calculate it. But in the real world, it's possible to see zero particles inside a respirator, at least for the duration of a fit test. Most probably not for the whole work practice time, but for a fit test, I already saw that, yes.
Okay, thank you. I don't see any other questions. And looking at the time, we still have 1 minute, so perfect timing. If there's indeed no further questions, if I'm not mistaken, you have maybe an additional slide? Yeah. So just to inform you that the next session of the mini webinar will be on September 18th, same time, and then we'll look at the CNP method, so the other quantitative test method. You do see a link, but if you go to our website and go to events, you will find it there announced. And when I send out the link to the YouTube channel where you will find the recording of today, I will also mention the next session. And then after the September session, we plan another session in November, where we will not talk about the technical data of or the technical information on how to or what the tests include, but more like how to start a fit test program. So what is necessary for implementing and what are do's and don'ts, and that is scheduled on November 20th. And with that, I would like to thank you all for your attendance, and hope to see you back in September. And in the meantime, do enjoy your summer break.
Thank you very much, and greetings from my side as well, and have a nice summer.